4 minutes late. I like mechanics a lot. Then why you are teaching? Because बच्चों को mechanics नहीं पता होता है, ठीक है? टीचिंग पे बाद में बात करूंगा बच्चा. क्लास के बाद पूछ लेना क्यों टीचिंग में, क्या क्या फायदे हैं टीचिंग के, and why do I want to be a teacher only? When I came to my native place, when I came to live with my parents, like in the month of July, there were so many relatives who met with me, and my father, my so many guys. All of them told me, do you want to stay in this teaching field? Do you want to be as a teacher? Like, do you want this field, this particular profession as your career in future also? Do you want this? Do you want to do this for good? I told them, yes. Problem kya hai? Everyone was asking me, why don't you apply for UPSC? Why don't you go for this? Why don't you go for that? Why don't you go for this? And all those things. I gave them simple one straight answer. Do you want your kids, do you want your grandkids to be taught by good teachers, at least a decent teacher? They said yes. I told them, if you want everyone to become an IAS officer, if you want everyone to become a kind of government official or a government employee working in some kind of, you can say, excise department or some kind of administration work, then how can you expect good teachers will come out of that? There is a right now there is a notion, at least in North India, jinka kuch nahi hoga, those who can't do anything, they'll become teacher. And I think that is the case in South India also. Jinka kuch nahi hota hai, wo teacher ban jate hain. And that is why there is a scarcity, there is a you can say a rarity of good teachers in the society. Ek to khud ka, they don't have that kind of self-motivation. Secondly, relatives and their parents. They want their kids to be taught by a good teacher, but they never want their kid to become a teacher. Education system में problem नहीं है, ये mental system में problem है. We don't respect the knowledge, we respect the authority, we respect the power which comes with it. We never respect the guys with knowledge, or the guys who are actually like making you or like shaping you in such a way that you'll have those powers. हम लोग सिर्फ result को क्या करते हैं ना, emphasis ज़्यादा देते हैं, उनको ज़्यादा value देते हैं. So in India, teachers have not been, they will be respected by the students, but none of the parents, no parent want their kid to become a teacher. If you say, I will become a teacher, they will judge you that you are not having very high dreams. You are a kind of average guy. It's okay. So you have to be like, काफी self-motivation आपके पास होना चाहिए. And I search that self-motivation in money. I will be very, very honest with you. I am self-motivated to continue doing the same thing, because here I can see the impact in 1 or 2 years. The impact that I can give, like that impact that I can actually produce, that I can see in 1 or 2 years. मुझे दिख जाता है. But we need some extra motivation, right? I search that self-motivation in money. I always give this, like, you can make understand, like an educated guy. You can make this understand to an educated guy, or to a guy who will understand these things. How will you make an old man or a guy with very conservative thinking understand this, that teaching is also good? So simply say this to them. Whatever amount I'm earning today, will I be able to earn the same amount of money if I'll be going to become a government official? If I'm going to become an IAS official also, if I don't do any kind of bad job or any kind of, you can say, corruption and all, I won't be able to earn this kind of money if I'll be doing those kind of government jobs. तो सबके साथ मैंने खुद को भी समझा दिया और उनको भी यही समझाता हूँ कि जितना मैं भी पैसे कमाता हूँ at this age, I won't be able to earn that kind of money if I'll be going to those fields. So this is a kind of excuse that I used to give to them. And to my second half, जो मेरा, like, I'm also part of them, right? So I also have that kind of fluctuation. I also have that kind of thought, like inside me somewhere. So I have to give something to that guy so that you keep quiet, I'll do my job. So to the society and to the Raushan, who is also part of that society, I used to give this as a मोटिवेशन पार्ट कि मैं इतना पैसे कमाता हूँ, वो मैं वहां नहीं कमा पाऊंगा. आई कांट डू करप्शन, आई कांट गो फॉर bribes and all. That will never going to happen in my life. So मैं जितना कमाता हूँ अभी नहीं कमा पाऊंगा. And secondly, the impact part, that is more important, that is the most important part. Yeah, I know few of you are saying, sir, हर teacher के साथ, I know few of, I won't be able to change the lives of all the students. I know that. That is why there are so many teachers from you actually, like you are being taught. You're being taught by a chemistry teacher, physics teacher, maths teacher, biology teacher, English teacher, right? You won't like all of them. You will like any one of them. So tuning कुछ लोग के साथ होता है, right? So it's okay ना. Anyway guys, sorry. And अथर्व आगे से सब start मत करना. Class के बाद start करना सब. फालतू का activate करा देता है रे. Anyway, शुरू करते हैं बच्चा लोग. Let's start our class. All right? बच्चा लोग, please try to solve this question. I think we have like studied the concept related to this. Try to solve this one. Pratish, I will come to that part. Okay, I'll come to that part after the class. Pratish is saying in Japan, teachers are at superior position. That is true. Correct. Hai? Education system in Japan is completely different. बहुत ही difference है वहाँ पे. I have one of my cousin, थोड़ा सा दूर का cousin है. He's working in Japan right now with Nissan Motors. So just few days back when I came, he came to meet me. So like I talked to him for an hour, and he told me so many great things about Japan and all. Education system कैसा है. So बहुत सारी चीजें थी. So Japan has a completely different education system. Yes, Pranav. That is quite impressive. चलो बच्चों लोग इसका आंसर करेंगे. When two polarities are crossed, then the light transmitted by first polaroid is completely blocked by the second polaroid. तो बताओ बच्चा, if you are using two polaroids and if, sir, not possible. Ganesh, क्या problem है? Light transmitted by the first polaroid is completely blocked by the second polaroid. How is this possible बच्चा लोग? अच्छा, answer not possible. Okay. Tell me guys, how these polaroids might have been adjusted or might have been arranged. Vijay is saying, क्या बोल रहा Vijay? This was a kind of paradox question I learned somewhere. अच्छा, क्या प्रॉब्लम है, क्या इसमें दिक्कत है विजय? You have to give the answer, na? Yeah, see, this statement suggests that those polaroids have been arranged so that their transmission axes are making 90 degree with each other. है ना? Answer yes है बच्चा, मिलेगा. Now question में क्या है? A student is interested to have some intensity of light transmitted. He wants some intensity. He doesn't want zero intensity. He wants some intensity transmitted by the second polaroid. So he inserted another polaroid between these two polaroids, bisecting the angle between them. ये थोड़ा सा repeat हो गया है. Bisecting the angle between them. So he has inserted. Consider करो कि if there are two polaroids, एक यहाँ पे है, एक यहाँ पे है. So if this is the transmission axis, second one will have transmission axis, something like this. All right. So that student will insert a polaroid. The student will insert a polaroid at an angle 45 degree. तो बाइसेक्ट करने का मतलब क्या है? इसके साथ 90 है तो क्या हो जाएगा 45. ठीक है. So we will insert a polaroid which will be bisecting the angle between the transmission axis for these two polaroids. So was he able to achieve his goal? देखते हैं करके. So let's say this is the first polaroid, this is the second polaroid, and this is the third polaroid. If intensity of the light striking the first polaroid is, let's say, I. Tell me guys, or let me call this as I only. ठीक है, मैं I ही बोलता हूँ. बोलो अच्छा, what will be the intensity of light after first polaroid? What will be the answer? It will be I by 2. Correct है? Why it will be I by 2? Because this is an unpolarized light. if an unpolarized light is allowed to pass through a Polaroid, the intensity after polarization will be what? Half of the incident one. So this will become I by 2. Yes, correct, bacha. Acha, what will happen after this? What will happen to the intensity after this? क्या होगा बच्चों? जल्दी से बताओ. It will become I by 2. Sorry. I by 2. अरे यार ये मैं yeah, I by 2 into cos square theta. What is the angle between the transmission axis of these two? 45. Cos square 45 is nothing but square of 1 by root 2. That is 1 by 2. Correct है? तो यहाँ लिख देंगे हम लोग 1 by 2. Clear है बच्चा लोग? अच्छा. What about after this? इसके बाद क्या हो जाएगा? बोलो बच्चा लोग. What will be the answer after this? What will happen after this? Same intensity. Why? यहाँ पे क्या? No light? अरे ऐसा नहीं है. I by 8 into cos square 45 again. Correct है? बिल्कुल Malus law apply करेंगे. We'll apply a Malus law here. After this क्या करेंगे बच्चा लोग? फिर से this is also polarized light, right? This is also a polarized light. So when this polarized light will be allowed to pass through a Polaroid, if the angle between the transmission axis is again 45 degrees, तो यहाँ पे ये आंसर क्या मिल जाएगा आपको? I by 16. क्या हुआ प्रतीश? कुछ लोग कुछ तो डाउट पूछ रहे हैं, समझ नहीं आ रहा. फाइनल आंसर इज I by 8, फाइनल आंसर इज I by 4. क्या प्रॉब्लम है? जल्दी बताओ. प्रतीश इज सेइंग उधर लास्ट में I by 4 है cos के पीछे. I by 4 है cos के पीछे. Why I by 4 है cos के पीछे? No. Okay, यहाँ पे या correct. This is I by 4. Sorry. This is I by 4. My bad. So answer is कितना बच्चा लोग? I by 8. I thought you were saying here. No, it's correct. ठीक है बच्चा लोग. तो I by 4 into cos square 45 is what? I by 8. तो incident intensity का 1 by 8 portion will be what? Transmitted. बाकी क्या हो जाएगा? Block हो जाएगा. So Polaroid works on कौन से principle है बच्चा लोग? Selective absorption. So it will absorb selective electric field vectors. All right. So this is the answer. Guys, click yes if you have understood this. बच्चा लोग click yes if you have understood this. समझ में आया सबको? मजा आया? ठीक है. चलो बच्चा इसका आंसर करेंगे. So two Polaroids are oriented with their planes perpendicular to incident light. Two Polaroids are oriented with their planes perpendicular to the incident light. ये थोड़ा सा confusing है, don't worry. सिर्फ समझो कि इनको orient किया गया है. Yeah, no problem. Perpendicular to the incident light. Transmission axis making an angle of 30 degrees with each other. What fraction of incident unpolarized light is transmitted? What fraction of incident unpolarized light is transmitted? मतलब कितना fraction of intensity मिलेगा तुम्हें? बस वो बता दो. So दो Polaroid use करने का. So this is one of the Polaroid. This is the other Polaroid. If this is the transmission axis, this is the other one. This is the transmission axis for the second Polaroid. Angle between them is 30. चलो चलो जल्दी से बताओ. 9 by 32, 3 by 8. 9 by 32, 3 by 8. Guys, don't give me the answer for amplitude. Give me the answer for intensity. तो आसान है ना. Unpolarized light will have, let's say, intensity I. After this, if unpolarized light will incident or will be allowed to pass through a Polaroid, after the Polaroid, I by 2 will be the intensity of light that will be obtained. इसके बाद क्या use करेंगे? Either you have to use the Malus law. All right. So here you are going to get I by 2 into cos square 30. So answer मिलेगा I by 2 into root 3 by 2 is what? 3 by, उसका square is what? 3 by 4. So this will give us the answer as 3I by 8. तो कितना पोर्शन हुआ चलो? So 3/8 fraction. That means how much percentage? तो fraction अगर देखो तो कितना हो जाएगा? So if you convert this into decimal, 3/8 is what? कितना fraction? Decimal बताओ. बोलो चलो. 0.375. Or you can say it is nothing but 37.5% of the intensity will be observed or will be obtained after the second Polaroid. तो ये इसका आंसर मिला. बच्चा लोग ऐसे ही क्वेश्चंस पूछे जाते हैं फ्रॉम मैलिस लॉ. दिस इज द टाइप ऑफ क्वेश्चन दैट विल बी आस्क्ड लाइक दिस. एंड लास्ट क्लास आल्सो वी हैव सॉल्व्ड वन और टू क्वेश्चंस, राइट? सो क्वेश्चन ऐसे ही पूछे जाएगा. They can also ask you what will be the intensity of light after nth Polaroid, and the angle is, let's say, theta between them. Angle between the transmission axis, let's say, theta. तो मेरा क्वेश्चन आपसे अभी मैं कर लेता हूँ, कुछ पूछ लेता हूँ, ठीक है? N Polaroids are used. ठीक है? Intensity of unpolarized light is I. Intensity after nth Polaroid will be. Answer करो. बोल बच्चा. There are n Polaroids that are used. Intensity of unpolarized light. ये थोड़ा सा ध्यान देना. Angle consider करो theta. Angle between transmission axis. Angle between transmission axis of every pair of Polaroid is, let's say, theta. ये थीटा मान लो, ठीक है? करो बच्चा. कैसे सॉल्व करोगे? जीपी मिलेगा? आर यू श्योर? Come on guys, give the answer. 1/2 to the power, okay, 1/2 to the power n cos square theta into I. Okay, Vishrut is saying 1/2 into cos square n minus 1 theta. कैसे कैसे आंसर कर रहे हो तुम लोग? देखो अच्छा, डायग्राम बना लो, बाकी तो खुद कर लोगे आप. ये मान लो यहाँ पे एक पोलरॉइड लगाने का, दूसरा इधर, थर्ड वन, फोर्थ वन, nth वन. ऐसा कुछ है, ठीक है? So here intensity is I. यहाँ क्या मिल जाएगा? I/2. So after this only you have to start. This is the first one. So how many Polaroids are left? One, like n minus 1. ये n हुआ तो कितना बचा भी? n minus 1. This is 1/I/2. So now what will be the intensity here? It will be I/2 into cos square theta. What will be the answer here बच्चा लोग? तो I/2 into cos square theta into cos square theta. Correct है? Then आगे, if I ask you further, then what will be the answer? So this is what? This is the first one. This is the second one. This is the third one. This is the fourth one. Come on guys, give the answer. What will be the intensity after this one? यहाँ पे क्या मिलेगा? तो I/2 into cos to the power 4 theta into cos square theta. So after first क्या मिल गया? I/2. यहाँ तक तो आपको कुछ ध्यान लगाना नहीं है. After second we got I/2 cos square theta. After third we have got I/2 cos to the power 4 theta. After fourth I have got I/2 into cos to the power 6 theta. This is nothing but So after nth Polaroid, what will be the intensity? Come on guys, give the answer. 2 into n minus 1. Are you sure? 2 in theta nahi hoga na. Like few of you are saying like this, sir, cos to the power 2 into n minus 1 into theta. तो cos to the power 2 into n minus 1 into theta. ये आप लोग का आंसर है. Guys, tell me whether this is correct. Guys, tell me whether this is correct. Is it correct? Yes or no? नहीं, बहुत लोगों ने 2n minus 1 दिया है. पुट करके देख लो ना, वेरीफाई कर लो, वेरीफाई दिस. आफ्टर सेकंड इफ आई पुट 2 हियर तो क्या मिल जाएगा? 2 into 2 minus 1. आफ्टर थर्ड व्हाट विल बी द आंसर? तो 2 into 3 minus 1 दैट इज 4, है ना. आफ्टर फोर्थ तो 2 into 4 minus 1 6. आफ्टर फिफ्थ क्या मिल जाएगा? cos into आफ्टर फिफ्थ व्हाट विल बी द आंसर? cos into 2 to the power 5 minus 1 into theta. मतलब सॉरी थीटा, मतलब क्या मिलना चाहिए? 8. Are you going to get 8 बच्चा लोग? तो yes मिलेगा, that cos square theta will be multiplied, so it will become 8, right? That means this is correct, no problem. So you can write this is the correct answer. और इसको मैं erase करता हूँ. You can write like this as well. I by 2 into cos theta to the power 2n minus 1. Guys, did you understand? Do you have any doubt here? क्या दिक्कत? अच्छा ठीक है ना, ये ब्रैकेट ले. Clear है? So this is the answer for this question. Guys, now we'll study polarization because of reflection. However, light can be polarized. मैंने कुछ गड़बड़ किया क्या? Okay. अरे यार क्या हो रहा है मेरे साथ? धोखा. अभी ठीक है? चलो. So guys, light waves can be polarized using reflection, using refraction, using scattering as well. But they cannot be experimentally, they cannot be controlled properly. ठीक है? Polarization can occur because of scattering also. ठीक है? Because of refraction also, because of reflection also. But करते क्या है? You can control or you can actually observe that if incident light wave like this, just imagine this condition. If there's a light wave incident on a interface, we know that part of it will be refracted, part of it will be what? Reflected. So we have observed that reflected ray will be reflected light wave will be partially polarized. Refracted light wave will also be partially polarized. If we change the angle of incidence, amount of polarization in reflection or amount of polarization in the refraction part will be what? Different. But this special case, there is special condition that we have obtained, or a special arrangement that we have obtained, that if angle of incidence, or if this reflected ray and refracted ray makes an angle of 90 degree with each other, then we got that all the reflected waves or all the reflected light waves will be completely or fully polarized. ठीक है? तो हमने क्या देखा कि during reflection, if angle between reflected wave लिखता हूं मैं, reflected wave and refracted wave is 90 degree, then reflected wave is completely polarized. Guys, I have a question for you. How will you identify whether the wave coming out of or coming is completely polarized or fully polarized? Tell me guys, how will you identify that? What is the method to identify whether light wave is completely polarized or partial polarized? कैसे पता करते हो? Yesterday I have told you. इंटेंसिटी हाफ नहीं रहे. Imagine if this is the reflected wave coming out of this interface. ठीक है? How will you identify whether this ray is completely polarized or not? याद करो बच्चों, yesterday I have taught you that if you place a Polaroid here and if you rotate this Polaroid, what will happen? क्या होगा बच्चों? If a polarized light is coming from here and if you rotate the Polaroid here about this axis, about the propagation of light wave, tell me, what will you observe? You will observe the intensity will vary from a maximum value to 0. So if you get a position where the intensity of light becomes 0, that means this reflected light wave contain, or this reflected light waves, or in this reflected light waves, electric field vectors are oscillating in one direction. है ना? समझ में आया बच्चा लोग? अरे नहीं रे प्रतीश, क्या बोल रहा है तू? वो अनपोलराइज्ड की बात करते हैं ना प्रतीश. मैं क्या बोल रहा हूँ? कंप्लीटली पोलराइज्ड. कल का लेक्चर तुम्हें याद नहीं है क्या? लेट मी सी, कल का लेक्चर देखो. कल के लेक्चर में लिखवाया मैंने, देखो. Polarized light resultant intensity changes from maximum I to 0. When the let's say this is the transmission axis for this one, and if transmission axis for this Polaroid is also vertical, the full light wave will what? Pass through it. So you'll get an intensity I. If the oscillation or oscillatory axis is this one, and if the transmission axis is somewhere like it has been made like this, but it has been rotated in such a way that transmission axis is horizontal. So none of the electric field vector, none of the light will be allowed to pass through it. All of them will be what? Absorbed here. The intensity that you're getting out of the Polaroid is what? 0. So from maximum to 0 आपको मिलेगा किसमें? In case of polarized light. So how will you identify whether the light wave is polarized or not? तो करेंगे क्या? आप ले लो एक Polaroid and rotate it completely. There'll be one position at which intensity after the Polaroid will be 0. If you get that, that means there is a position, or you can say all the electric field vectors are oscillating in only one direction. And if you make sure the transmission axis of the Polaroid is perpendicular to that, what will happen? None of the light will be allowed to pass. So that will give you an idea. तो कैसे आइडेंटिफाई करेंगे? समझ में आया प्रतीश? तुम्हें डाउट था? चलिए, तो so during reflection we have observed that at some angle of incidence, when reflected wave and refracted wave are making an angle 90 degrees with each other, then we have observed that reflected wave is what? Completely polarized. ये क्या हो गया बच्चों लोग? Completely polarized. ये जो है, ये किसने बताया था basically? This have been given by Brewster. ठीक है? This statement has been given by Brewster. तो इसको हम किसके नाम से पढ़ेंगे? ब्रूस्टर्स लॉ के नाम से पढ़ेंगे. So incident light unpolarized, reflected light plain polarized or completely polarized. This is air and glass, so there is a change of medium here. So part of it is what? Getting reflected, part of it is what? Getting refracted. In refraction, you'll find some partial polarization. Okay, partial polarization. So now the condition here is what, bachalo? Condition here is what? This is what? 90 degree. This angle is kitna? 90 degree. Can we get some relation out of this? So देखते हैं, try करके देखते हैं. This is what? 90 degree. Guys, tell me what is the relation between IP and RP? This IP is called as Brewster's angle. इसको क्या बोलते हैं? चलो, Brewster's angle. How will you define this? This is the angle of incidence at which reflected wave will be completely polarized. तो बोलो चलो, what is the relation between this IP and RP? Or you can say IP and R only itself, no problem. RP का मतलब क्या होता है? मतलब ये हो गया polarization वाली बात कर रहे हैं ना. So tell me what is the relation between IP and RP? Pratish has given answer as IP will be equal to 90 minus RP. Is it correct बच्चा लोग? Has given an answer incident angle plus refracted angle will be equal to 90. That is correct only. कैसे? तो देखो, this is completely क्या बच्चा? 180. This full angle is what? 180. This is 90 degree. So IP plus RP must be what? 90. IP plus RP must be kitna bachcha log? 90 degrees. Now let us use Snell's law at the interface. Let us use Snell's law at interface. Can I write mu for air into sine I P will be equal to mu for the glass, let's mu, into sine of RP. I can write RP is equal to 90 minus IP, and sine 90 minus IP can be written as cos of IP. So I'm getting an answer as sine IP is equal to mu into IP. ठीक है? तो यहाँ से आंसर क्या मिल जाएगा बच्चा लोग? I can write this as tan of IP is equal to mu. So if I ask you to find the Brewster's angle for an interface, you can answer like tan of the Brewster's angle will be equal to refractive index of the glass. Or if you want to get the answer, get an answer for a general condition where this is, let's say, mu1, this is mu2. So you can write like this as well. You can write this as tan of IP is equal to mu2 divided by mu1. No problem. Tan of IP is equal to mu2 divided by mu1. मैंने सिमिलर क्वेश्चन होमवर्क में दिया था रे ऑप्टिक्स में तो नहीं दिया होगा. ठीक है चलो, तो ये फॉर्म आप प्लीज याद रखना. गाइस कुछ याद आ रहा है? कुछ क्रिटिकल एंगल से कुछ लेना देना है क्या? गाइस if I ask you to find critical angle for this condition, what will you answer? If I ask you find the critical angle at this interface, what will be the answer? How will you get that answer? If let's say this is mu, this is 1. If I ask you to get the critical angle, तो क्या लिखोगे? Sin inverse 1 by mu. Correct है ना? Sin inverse 1 by mu, right? So sometimes you will be asked a question related to critical angle also. As you can see in this question suggests that the critical angle for a medium is given to you. Find its Brewster's angle. Tell me guys, what will be the answer here? You need to find what will be the Brewster's angle. So what is the meaning of this sin inverse 3 by 5? It means that a critical angle क्या बता रहा है? It is nothing but theta c is equal to sin inverse 1 by mu. This suggests, or this is equal to, actually it is given to you as sin inverse 1 by 5 by 3. That means mu is given to you as 5 by 3. If mu is given to us 5 by 3, I can write tan IP is equal to 5 by 3. So tan inverse, or simply IP is equal to tan inverse of 5 by 3. No problem. This is the answer. Yes, Hari Prakash, correct. Vishruth, correct. अरे प्रतीश 37 5 by 3 होता है क्या? Are you sure? कुछ भी कोई वैल्यू नहीं रही है अलाउड. Yes, Ravi Kiran. Yes, correct. Guys, did you understand this? अरे कुछ म्यू व्यू कुछ नहीं भी दिया है तब भी तो मिल जाएगा ना. If you don't consider 1 by mu, you will consider this as what? mu1 by mu2. So mu1 by mu2 is 3 by 5. So mu2 by mu1 will be 5 by 3. Ravi Kiran, will that change? कोई change नहीं होगा ना. In case of mu1 and mu2, you write theta c is equal to sin inverse of mu1 by mu2, right? ऐसे लिखते हो ना आप लोग. ये क्या होता है? Denser by rarer. So in the same way you can write it here also. कोई problem नहीं होगा. All right guys, try to get an answer for this one. अरे बच्चों लोग पोलराइजेशन से क्वेश्चन बहुत कम आता है यार. और ऐसे ही क्वेश्चंस आता है. When the angle of incidence on a material is 60 degree from air, the reflected light is completely polarized. What is the velocity of refracted ray inside the material in meter per second? आंसर करिए जल्दी से. When the angle of incidence on a material is 60 degree, the reflected light is what? Completely polarized. Root 3 into 10 to the power 8. Okay, Darshan is saying C by root 3. That means same. Ganesh is also saying the same thing. Rupi is same. Anisha is also saying the same answer. चलो find out करते हैं. बहुत easy question है. How will you find what is the speed or velocity of light inside that material? So we know that mu for any medium is nothing but V divided by C. So V will be equal to mu into C. So I need to find what is the value of mu. So mu कैसे निकलेगा? We know that tan IP is nothing but mu. So if I know the value of tan IP is कितना? चलो 60 degree. This will. So mu is nothing but root 3. So using this part, I can write V is equal to by root 3 क्यों लिखा था आपने? ऐसा मैंने गलत लिखा. Sorry. ये बार बार मैं क्यों चेंज गड़बड़ करता हूँ? C by V, right? Correct. C by V. So V will be equal to C divided by mu. Correct है? तो yeah, C divided by mu. तो C by root 3. So it will be C is 3 into 10 to the power 8 divided by root 3 is what? Root 3. So root 3 into 10 to the power 8 meter per second is the correct answer. सबको करेक्ट आंसर है. ठीक है, बहुत बढ़िया, धन्यवाद. चलो थैंक यू. अब आगे बढ़ते हैं. कुछ लोगों को ज्यादा खुजली था, सर एप्लीकेशन बताओ कहाँ यूज होता है पोलरॉइड का. तो सबसे पहला एप्लीकेशन है बच्चा सन ग्लासेस में, जो कि आप नॉर्मल ब्रांड का खरीदोगे नहीं मिलेगा. ठीक है, कहने की बात है सिर्फ. बट होता क्या बच्चा लोग कि लाइक एज यू कैन रीड हियर आल्सो, व्हेन पोलराइज्ड सन ग्लासेस अनक्रॉस्ड, मतलब कि जिसमें क्रॉस नहीं दिया हुआ, so the transmitted light is dimmed due to the extra thickness. Normal जो tinted आप प्लास्टिक खरीदते हो ना, तो लोग ऐसे आपको बेचेंगे. Like have you, अच्छा guys, how many of you have gone to this Lenskart? Lenskart का रिटेल ऑफिस, रिटेल स्टोर में कितने लोग गए हो? How many of you have gone to Lenskart retail store? गए हो क्या? They'll keep a Polaroid glass in their store. कभी ऐसे घूमते घूमते चले जाना लॉकडाउन के बाद, मतलब जब if you are allowed to go. Just go to Lenskart का retail store में, Lenskart store. You'll find they'll keep one table. उस टेबल पे कुछ एक ऐसा इधर एक पोलरॉइड ग्लास रखेंगे. वो पूरा शो ऑफ कर रहा है. ठीक है, they'll have a glass, उसके ऊपर में पोलरॉइड का एक फिल्म लगवाएंगे. It will go like this. ऐसा होता है ना डबल शीशा वाला. So they'll have a glass, simple glass like this, and they'll install one Polaroid sheet or thin film above this. अरे हुबली में है रे, मैं गया हूँ हुबली में. हुबली में बताता हूँ कहाँ है. सिगड़ी देखा है? सिगड़ी रेस्टोरेंट, उस एरिया में देखा मैंने. उस एरिया में है, फिर कहाँ पे है? देश पांडे नगर, समवेयर आई हैव गॉन. हुबली में लेंसकार्ट का है, आई हैव गॉन देयर. ठीक है, सो दे विल हैव अ फिल्म ओवर इट. ठीक है, हाँ हुबली में देखो दो है, धारवाड़ में एक है. सो व्हेन दे विल अप्लाई अ फिल्म ओवर इट, दे विल हैव अ स्क्रीन. एक लगेगा कि एक छोटा सा स्क्रीन है, उसमें कुछ यू विल फाइंड सम काइंड ऑफ बलून और सो, or you'll find simply green ground. When they'll apply the film, you'll find a plane landing on the like you'll find a plane also in that picture. ठीक है, वो क्या होता है? polarization का ही कमाल है. That is the effect of Polaroids that they are using. So when you are actually the light that are coming from that aeroplane, they are coming at such an angle कि वो क्या करेगा, उसको आप देख नहीं पा रहे हो. And if you, अरे वो जुगाड़ लगाते हैं उस तरीके, पूरा ऑप्टिक्स का कमाल है. ठीक है ना, वैसे ही आप सन ग्लासेस में भी आपको पोलरॉइड्स मिलेगा. यू हैव टू पे अ लॉट ऑफ मनी फॉर दैट. आपको अगर अच्छा पोलरॉइड चाहिए, अच्छा ग्लासेस चाहिए, इफ यू नीड एक्चुअल पोलरॉइड, तो उसके लिए आपको पैसा एक्स्ट्रा लगाना पड़ता है. सो बट लोकल ब्रांड्स क्या करेगा, दे विल से कि देखो इफ यू आर गोइंग टू सनलाइट, थिकनेस बढ़ जाएगा, घट जाएगा, ऐसा करके देन दे आस्क कि दे विल से कि इसमें एक्स्ट्रा एक पोलरॉइड लगाते हैं, पोलराइजर लगाते हैं, that will actually decrease the harmful effect of sunlight and then they'll say sell that particular sunglasses. But actually वो कुछ नहीं होता है, they'll simply make the tint plastic actually thick, उसको थोड़ा मोटा कर देंगे तो इंटेंसिटी क्या कम करके दिखेगा आपको, ठीक है। अब एक्चुअली क्या होता है, however when they are crossed का मतलब देखो यहाँ ये सिंपल हुआ, तो क्या करते हैं ये क्रॉस बनाते हैं, मतलब कि एक लेट अस से कि इफ यू आर यूजिंग अ पोलरॉइड लाइक दिस, so this will have, let us say, this axis of transmission, then they will use one more polaroid above like over this, and that will have thoda sa iska perpendicular direction. So more number of sheets, more number of polaroid films that you are going to apply with different axes that you are going to apply on that glass, it will absorb more electric fields, or it will absorb more electric field vectors having different transmission axis, having different oscillatory motion. तो ये पोलरॉइड के लिए क्या डिफरेंट फिल्म्स यहाँ देखो क्रॉस किया है, एक इसका एक कुछ ऐसा होगा, कुछ इसका ऐसा होगा, वो दोनों के मिला के ग्लास बनेगा, उसके ऊपर मल्टीपल फिल्म्स लगाए जाते हैं पोलरॉइड के, ठीक है। तो पहला आपका यूज कहाँ जाएगा, चलो सन ग्लासेस में, बिकॉज इंटेंसिटी कम करना है ना मुझे। ट्रेन्स और एरोप्लेन में, या यू कैन से दैट this polaroids are being used in the windscreen of this aeroplane, train, car, जो भी उन सब के windscreen में भी यूज होता है, कार विंडोज में भी यूज कर सकते हो, करेक्ट, बट विंडस्क्रीन में ज्यादा, बिकॉज होता देखो क्या है कि इमेजिन करो ये आपका विंडस्क्रीन है, ठीक है, एंड दिस विंडस्क्रीन विल हैव कुछ लेट्स से कि राइट इस तरीके का कुछ इस तरीके का एक ट्रांसमिशन एक्सिस बनाया, इसके ऊपर क्या करेंगे, इसके ऊपर एक और फिल्म लगाएंगे, they will also apply, they'll apply one more film over it and that will have a transmission axis like this. So when the car or the vehicle coming from front, when they'll have their light, they'll have their own fog light and all, so they will fall on this windscreen, आगे वाले स्क्रीन पे जब fall करेगा, so most of the light will be absorbed by this film or this glass, so you'll get less shine, you'll get less sparkle. समझ में आ रहा? अदरवाइज क्या होता है बच्चों लोग, आगे से अगर कोई गाड़ी आ रही है आपको कुछ दिखेगा ही नहीं, आपको कुछ नहीं दिखेगा। Few of you will say, sir, if those lights are not coming to us, how we are going to see the road? They will ask, sir, if we are blocking the light coming from the other vehicle, how we are going to see the road? अरे तेरा अपना भी तो लाइट है ना, तेरी गाड़ी में अपना भी तो लाइट लगा है ना, you'll see the road because of your own light, because of your own vehicle's light. That is not being blocked, right? तो वो तो आराम से दिखेगा तुम्हें, तुम्हें मिनिमल विजिबिलिटी चाहिए ना, ऐसा विजिबिलिटी चाहिए, you can see the road, you can see someone on the road, but the extra brightness that is coming and falling onto your eyes and which is disturbing the actual vision, that will be blocked by the Polaroid windscreen. समझ में आया? The same thing happens with the aeroplane and trains as well. क्लियर है बच्चों लोग, समझ में आया क्या? पॉइंट है, पॉइंट ऐसा सोचना है ना कि वो गाड़ी में, तुम्हारे भी तो गाड़ी में लगा हो रहेगा ना, एरोप्लेन में रनवे नहीं दिखेगा, बहुत सारी चीजें हैं ना, नहीं दिखेगा, बाकी और लाइट लगाते हैं ना। अरे तुम्हें लगता है, अच्छा प्रीतिश इज सेइंग सर एरोप्लेन में रनवे को देख के लोग लैंडिंग कराते हैं क्या? डू यू थिंक दैट पायलट्स विल लैंड ऑन द रनवे व्हाइल सीइंग द रनवे? वो सब ऑपरेटेड होता है, सब उनका कैलकुलेशन वाइज होता है। इफ दे आर गोइंग टू सी द रनवे एंड ऑल दोस थिंग्स, तब तो हो गया, कहानी खत्म। वो बारिश में कुछ अंधेरा आया, लाइक वो लोग बहुत पिच डार्क में भी तो लैंडिंग कराते हैं ना, या लाइट्स आर देयर ऑन द रनवे, कुछ तो गड़बड़ हो सकता है ना, प्रॉपर उनका प्लान्ड होता है, उनको प्रॉपर नेविगेशन सिस्टम उनका अच्छा होता है, दे विल हैव देयर प्रॉपर नेविगेशन सिस्टम, दे विल हैव देयर ओन ऑपरेटिंग प्रोसीजर्स, दे हैव टू फॉलो दैट। हाइट कितना है, स्पीड कितना है, एवरीथिंग विल बी लाइक डिजिटलाइज्ड देयर, ठीक है। चलो, तो ये ट्रेन और एरोप्लेन में दिख गया। एज यू कैन सी हियर, देखो, पोलराइड्स आर यूज्ड टू एलिमिनेट द डैजल फ्रॉम द हेडलाइट्स ऑफ कार एंड बसेस, कहानी यही आया, ठीक है। So they are used to eliminate the dazzle from the headlights of car and buses. But normally क्या होता है, आपका अगर गाड़ी मतलब नॉर्मल ब्रांड का है, ठीक है, मारुति सुजुकी का कुछ आपने 10 लाख का गाड़ी खरीद लिया, तो जो स्क्रीन होता है, the screen that you're going to get, that won't be having that those many layers of polaroids. So they won't be able to actually like reduce the dazzle a lot. If you want to get a like proper designed windscreen, तो उसके लिए एक्स्ट्रा पैसा लगाना पड़ेगा, ठीक है। or there are multiple applications also. They are used to record and reproduce three-dimensional moving pictures. कैसे होता है? Don't ask me. बहुत बड़ा science. I can't explain that to you. All right. Polaroids are used in photoelastic stress analysis. You will say, sir, photoelectricity मेरे को मालूम नहीं, elasticity मालूम नहीं. ये देखो क्या पढ़ा रहे हैं. Photoelastic stress analysis. I also don't know. I have very small idea about this. So Polaroids are used in photoelastic stress analysis. Abhi boards mein this is not going to ask. So these things are irrelevant if you study this just for the knowledge, just for the information. You can remember this. Otherwise, the most important applications are this one: sunglasses, train aeroplanes, and to remove the dazzle. बाकी कुछ समझ में नहीं आएगा. एक आध देखते हैं समझ में कुछ आ जाए तो. The microscopes fitted with Polaroids enable us to see very minute particles which are otherwise not seen properly due to glare of the light. ये एक application that is like that we can understand. ठीक है? So because of glare of the light, if we can't see minute particles, these Polaroids will help us to see those very minute particles as well. LCD. So Polaroids are used in LCD, liquid crystal display. In calculators, watches, uses the principle of polarization to form numbers and letters. So to form numbers and letters on calculator, हम क्या करते हैं चलो Polaroid का use करते हैं in calculator. Calculator में करेंगे use, watches में, digital watches में use करेंगे. All right. Polarized laser beams are used as needles for producing sound from compact disc in CD players. अरे अथर्व, can you see the logo here? Can you see the logo here? क्या है? अवंती का ही तो है ना? वहीं से तो मैंने कट कॉपी पेस्ट किया है. ठीक है, चलो. So these are the actually applications of Polaroid. If this topic would have been there in board syllabus, you have to remember like 3 to 4 applications. कभी कोई पूछ देगा, what are the applications of Polaroids? Because that question have been asked already. So, but since this portion have been deleted from your board syllabus, you don't have to actually remember them. Just remember few of the you can say popular applications. तो wave optics में बस इतना ही पढ़ाऊंगा मैं. After this, I'm going to start electromagnetic waves. And in electromagnetic waves, I'll start with the displacement current. ठीक है? प्रतीश मत पूछ बच्चा, मत पूछ. मैं मर जाऊंगा, तू ही मरेगा. ठीक है? पहले तो तुझे मटेरियल साइंस पढ़ना नहीं है. You don't know what is crystal first. वो 1 घंटे का मुझे समझाने में लग जाएगा क्रिस्टल बनता क्या है, कैसे बनाते हैं, उसमें सिमेट्री क्या होता है, सिमेट्री क्या होता है. यस प्रणव, मैंने पता है ना. अरे यार बड़ा होता है स्क्रीन ना. ये क्या रे प्रणव, तू भी सबके अलग अलग एप्लीकेशंस हैं प्रणव. ठीक है ना. So guys, we are going to start with the electromagnetic waves, and in electromagnetic waves we'll study the concept of displacement current, which has been deleted from board syllabus, but it is there in comparative. ठीक है, बहुत छोटा सा टॉपिक है, और I won't be teaching you the history of electromagnetic waves today. ठीक है, when I'll be teaching you the boards portion for this, I'll tell you the exact पूरा scenario कैसे बना, क्या हुआ, सब बताऊंगा. But today I'll simply talk about the displacement current, the concept of displacement current. Why we have to talk about displacement current. थोड़ा सा Maxwell का बताऊंगा कि how Maxwell has actually come to this point. So this concept of displacement current has been given by Maxwell. ठीक है, वो player Maxwell नहीं. तो basically हुआ क्या था बच्चा लोग, कि actually he has done an experiment. Experiment कुछ ऐसा था. He's taken actually to prove this displacement current. To actually पहले मैं ये पूछता हूँ आपसे, ये बताओ पहले. If you are having, let's say, imagine this is a current, this is let's say a loop, a conducting loop, and there is a magnetic field. There is a magnetic field in which this loop has been placed, and this magnetic field is changing with time. Imagine a conducting loop has been placed in a time varying magnetic field. Tell me what will happen in this conducting loop. क्या होगा यहाँ पे बच्चों? So you'll find some current will flow, right? यहाँ पे क्या हो जाएगा बच्चों? Some current will flow. So tell me why this current will flow here. How this current will flow? We have studied ये हमने कहाँ पढ़ा है बच्चा लोग? इलेक्ट्रोमैग्नेटिक इंडक्शन में. बिफोर दैट वी हैव स्टडीड फॉर करंट टू फ्लो वी नीड चार्जेस और वी नीड एटलीस्ट इलेक्ट्रिक फील्ड, है ना? So we have studied this, that to enable this induction of current there must be what? Induced electric field. तो हमने क्या पढ़ा इस कहानी में? हमने पढ़ा था कि that changing or time varying magnetic field will produce induced electric field. Right? वही तो बता रहा हूं ना Pradesh Patil. That is what I'm telling now. Normally in current electricity we have studied that for current to flow charge की जरूरत है. But then we have studied that even if there is a time varying magnetic field is there, current can flow. So current can also flow in the presence of time varying magnetic field. How does it happen? So this time varying magnetic field will produce induced electric field, and this induced electric field is actually responsible for flow of current. All right. Then actually this Maxwell have thought of कि is reverse of this is true, क्या इसका reverse true है क्या? And the source of this inspiration, source of this question was this simple experiment. इसका source जो था वो simple experiment था. वो क्या experiment किया उन्होंने? That he has taken a capacitor. ठीक है? He has taken a capacitor. He was taken a capacitor that is being charged. तो बच्चा लोग when this capacitor will be charged, यहाँ plus यहाँ minus हो रहा है, इधर से ऐसे कुछ charge का flow, right? So in charging of capacitor, we know that पहले तो हमें पता है कि Q जो होगा, sorry, I जो होगा वो क्या होगा बच्चा लोग? तो I will be equal to dQ by dt. So in this particular charging capacitor, he has placed a magnetic needle. यहाँ उन्होंने क्या किया? एक magnetic needle को place किया. So when magnetic needle was placed here, what do you think must have happened? बोलो बच्चा लोग. If you are going to place a magnetic needle here, tell me what will you observe? Come on guys, tell me. If you are going to place a magnetic needle here, what will you observe here? Deflection, right? What will you observe? Deflection of magnetic needle. Let's say this is north, this is south. Correct है? अच्छा. But at the same time, he has placed this magnetic needle inside this capacitor also. He has placed this magnetic needle inside the capacitor also. What do you think might have happened? Yes, Vijayata, you can do at the end, no problem. बोलो बच्चा लोग. What do you think that might have happened? So you'll say, sir, no deflection, because the reason for deflection here is nothing but current. The reason for deflection here is nothing but current. Because of this current, there will be magnetic field here. And when this magnetic compass, when this magnetic needle has been placed in the magnetic field of this current carrying wire, this magnetic needle must have responded to that and must have deflected. But when we talk about this area, nothing is there. Even if you apply this Ampere circuit law, you'll get that Ampere circuit law suggests line integral of B dot dl is nothing but mu naught into I. But in this region, there is no any current. So if there is no any current, what will happen? According to Ampere circuit law, B is 0 inside the capacitor. Right? B is what? 0 inside the capacitor. Hence, no deflection of needle is possible. So according to Ampere circuit law, this particular needle must not have deflected. But in real life, it deflects. Okay? But in reality, but in reality the needle deflects. Inside the capacitor also, inside the capacitor as well. Abhi after this the problem of Ampere starts. Ampere ने तो कुछ मस्त सा रूल दे दिया, लॉ दे दिया. On his name the unit of current has also been given, है ना? So he was a kind of well established researcher or physicist. तो इसके बाद परेशानी शुरू हुआ. परेशानी क्या हुआ? Now Maxwell was saying that if you say that there is no any current here, so there should not be any magnetic field, so there should not be any deflection here. But how this needle deflects? तो क्यों deflect कर रहा है? Because for this magnetic needle to deflect, there must be a magnetic field. Because if magnetic field is not present, it cannot deflect, है ना? तो अब उसका सवाल था, he was asking everyone, give me the reason for this. No one could have answered, because everyone has actually agreed to this part, that for a magnetic field to exist, there must be a current carrying wire, or there must be current. But there is no any current in this region. So if there is no any current in this region, how can magnetic field will be there? बात समझ में आ रही है? Then he has given a theory. Maxwell ने क्या बोला? चलो, Maxwell suggested as you have studied that time varying magnetic field will produce induced electric field. Similarly, time varying electric field will produce magnetic field as well. See, if this question would have been asked right now, you would be able to answer this. Like in nature, you will find so much of symmetry. आपने de Broglie जो theory है वो भी पढ़ा होगा, आपने de Broglie wavelength पढ़ा होगा ना? So how this de Broglie has explained the wave theory, dual nature. So he has explained what is the suggestion by de Broglie. He told कि in nature symmetry exists at all the conditions, at all the places. So if time varying magnetic field will produce induced electric field, so time varying electric field will also produce magnetic field. At that point of time, this is the case in 1800, something 1820, 1830 के आसपास में, where these concepts were not present. So Maxwell has to derive it. Maxwell has to actually give this as a new theorem. So he suggested that a time varying electric field, will produce magnetic field. But the problem for Maxwell didn't end here. He explained this to everyone. He was not a well-established guy in this field. So he explained this part to everyone. He told, you see, this is going to happen. Everybody agrees with this. Everybody agreed to this. Yes, there is a deflection. So what is the reason? So he gave this as a reason, that if you are going to change the electric field, you are going to get a magnetic field. But no one agreed. No one actually believed in him. Everyone says, no, current hona chahiye. Then what did he say? इसने दिमाग लगाया. Physics है, reasoning है. So he developed a concept. of displacement current. ठीक है? So to explain induction of magnetic field in a time varying electric field region, he gave the concept of displacement current. ठीक है बच्चा लोग, उन्होंने क्या बोला? इसको बताने के लिए उन्होंने बोला कि डिस्प्लेसमेंट करंट नाम का कुछ चीज होता है. तो होता है ना कि अपना नाक पकड़ो, तो ऐसे नहीं पकड़ना, तो उल्टा घुमा के पकड़वा दिया. ठीक है? So what did he actually explain? He explained that in this particular capacitor part, यहाँ पे देखो हुआ क्या. उन्होंने बोला कि when this capacitor is being charged, when this capacitor is what being charged, what happens? The charge on this plate increases. The charge on each plate what increases? So charge density on each plate increases. What will be the electric field inside the capacitor? That is sigma by epsilon naught. So sigma increases or sigma change increases. So if sigma increases, what will happen? Electric field increases. So now we have a reason where electric field is changing. And he has given an idea, he has given a concept of displacement current, and he has given the formula also. After so much of experiments, so many experiments, after so many dimensional analysis, he has given the value of displacement current, ID, as epsilon naught into d phi by dt. He has given that there will be a displacement current in this time varying electric field, and the value of displacement current will be equal to epsilon naught into d phi by dt. ठीक है, ये उन्होंने वैल्यू बताया. He has also said, he has also observed that the amount of deflection that occurs here for the needle, the same amount of deflection occurs for the needle here as well. तो यहाँ भी क्या होता है बच्चे लोग? Deflection, and that too by the same amount, by the same amount. So he has this thing in his mind that the current that is flowing from here, this current is called as conduction current. यहाँ पे क्या करंट कौन सा फ्लो करता है बच्चों लोग? कंडक्शन. He named this current as conduction current, and he named a current inside this as a displacement current. And he told that the value of conduction current and displacement current will be same. Just to explain this phenomenon, he named one current named as displacement current, and he's given the value also, that is epsilon naught into d phi by dt. And then he told the magnitude of conduction current here, magnitude of displacement current here will be same. And what is the reason for that? He told that since deflection of magnetic needle is same here, so I'll say the magnetic field present here is also same, and hence the magnetic field here is same, so displacement current must be same here. ठीक है बच्चा लोग? तो चलिए, अगर मैं आपसे पूछता हूं यहाँ पे, लेकिन बोर्ड्स इट हैज बीन आस्क्ड टू प्रूव, बट अभी तो खत्म हो गया, बट जरूरत नहीं, बट सिर्फ मैं आपको समझाने के लिए बता देता हूं, टू प्रूव IC इज इक्वल टू ID, दैट मींस कंडक्शन करंट इज इक्वल टू डिस्प्लेसमेंट करंट. सो गाइस, इफ आई आस्क यू टू राइट डिस्प्लेसमेंट करंट, बताओ क्या लिखोगे आंसर इसका? If I ask you to write displacement current, write epsilon naught into d phi. D phi की जगह क्या लिखोगे? d by dt of phi is nothing but electric field into area, right? Electric field into area. So this will be given as epsilon naught into A. ठीक है? And then you can write, wait a minute, एक मिनट रुक जाओ. Yeah, I can write this is what बच्चा लोग E into A. All right. Can I say this E and A? इसको अगर मैं बाहर निकालता हूँ, A बाहर निकल जाएगा. I'll get A into epsilon naught into d by dt of E. Can I write this? बोल बच्चा लोग जल्दी से. और कुछ और चेंज कर सकते हैं क्या? इसको ऐसे रहने देता हूँ मैं, ठीक है? Let me write like this. मैं दूसरा यूज करता हूँ. Guys, if I ask you to find the value of phi, phi का वैल्यू गॉस लॉ से क्या लिखोगे? If I ask you to write the value of phi, so phi is the flux. What will you write from the Gauss law? The value of phi. Can you say this will be equal to Q by epsilon naught? है ना? Q by epsilon naught. I was trying to derive something else. So it will be equal to epsilon naught into this epsilon naught is constant. That can be taken out. It will be in the denominator into d by dt of Q. What is dq by dt? This epsilon naught cancelled. So ID. So ID will be equal to dq by dt. बच्चा लोग थोड़ा सा यहाँ पे एक चेंज है. चेंज क्या है? What is this Q बच्चा लोग? Tell me. What is this Q here? So this can be actually written as IC as well. Tell me what is Q here? Is this the charge that is flowing in the conductor or in this particular circuit? The answer is not. That is not correct. ये dq by dt क्या है? This dq by dt is nothing but the change of rate of change of charge on the capacitor, and that is occurring through the conductor itself. तो दोनों इस केस में क्या हो जाता है? सेम हो जाता है. So that is why you can say this is nothing but dq by dt is nothing but the current itself. But हमेशा के लिए सही नहीं होता है वो. ठीक है? So this dq by dt is what? Because ये q किसके कारण आया था? चार्ज के कारण, चार्ज ऑन द कैपेसिटर के कारण. ऑलराइट. So from here you can say that this displacement current will be equal to conduction current. Okay, तो ये फॉर्मूला मिला मुझे. अच्छा, याद क्या करना है आपको? याद यही वाला फॉर्म करना है. You have to remember this form, that ID is equal to epsilon naught into d phi by dt. All right, guys. So, guys, click yes if you have understood the concept of displacement current. But chalo, click yes if you have understood the concept of displacement current. Why Maxwell has to give or had to give the concept of displacement current? Did you understand this part? क्या actual में ये मतलब exist करता है क्या? So answer is no. तो actual में ऐसा कुछ exist करता नहीं है. But just to explain this, just to like maintain the consistency of different laws of electromagnetism, he has to use this concept of displacement current. There are some characteristics of displacement current. ठीक है, पहला characteristic क्या है चलो? So displacement current has nothing to do with the current except that it adds to current density in the Ampere's law. तो actually हुआ ये था कि after this Maxwell has modified the Ampere circuit law. So we call that as modified Ampere circuit law, or it has been also called as Maxwell Ampere's law. ठीक है, and this says that line integral of B dot dl will be written as mu naught into ID plus IC. Simply told, क्या किया उन्होंने? सिर्फ ID को ऐड कर दिया. With the conduction current क्या कर दिया उन्होंने? ID को ऐड कर दिया. So this is called as the modified Ampere circuit law, or you can say this is called as the Maxwell Ampere's law. ठीक है, तो अब देखो यहाँ पे लिखा भी है इस characteristics में. Has nothing to do with the current except that it adds to the current density in the Ampere's law. Okay, it is called as the current because it produces the magnetic field. No one was actually agreeing to this fact that there is a magnetic field because of this changing electric field. So just to maintain this consistency of theorems and all the like assumptions, he called this as a current because it produces magnetic field, and we have studied that current will actually produce magnetic field. इसलिए इसका नाम क्या रख दिया गया? एक current के रूप में. अच्छा, what about the magnitude? तो magnitude of the displacement current is equal to the rate of change of electric displacement. इसका कोई लेना देना नहीं है. ठीक है, इसके बाद देखिए चलो. Unlike conduction current, the displacement current exists when there is a rate of change of electric flux. As I told you, if electric field will change, तो क्या हो जाएगा चलो? Magnetic field will be produced. So if there is a change of electric flux, then there will be a displacement current exist. If electric flux is constant, there will not be any talk about, there will not be any concept of displacement current that will exist. So for displacement current to exist, there must be change of electric flux. yes अतर वो आगे आएगा. ठीक है, वो बोर्ड्स में है तो मैं बताऊंगा आपको. इंट्रोडक्शन and the properties, Maxwell equations, all of those things will be taught to you in later class. मतलब कल या फिर मंडे को पढ़ाऊंगा. At points where there is an accumulation of charge and hence a discontinuity in conduction current, displacement current helps us to make the total current continuous across the discontinuity. So guys, when there will be an accumulation of charge, there we got a discontinuity. We say कि कोई current का flow ही नहीं हो रहा in a circuit. So just to understand, just to maintain the continuity in that circuit, we have to introduce displacement current. You can say this here, कि sir, when there is an accumulation here, during charging of this capacitor, the charges were what? Being accumulated. So हम क्या बोलते थे? यहाँ के बाद current है ही नहीं. So just to maintain this continuity part here, we also introduce displacement current here. So whatever the current that will come here, the same amount of current will reach here, but in the form of displacement current. So this will also eliminate the discontinuity in the accumulation of charges part. ठीक है? तो आप देख लो आप, at points where there is an accumulation of charge, hence a discontinuity in conduction current, displacement current helps us to make the total current continuous across the discontinuity. चलिए fifth point देखते हैं चलो. The displacement current is negligible in good conductor. इसका reason क्या है चलो? If you are talking about current through a conductor, displacement current will be zero because there the electric flux will not change, electric field will be constant. As compared to the conduction current at any frequency lower than the optical frequency. ये आपके syllabus के बाहर का चीज है, अभी समझने वाली बात नहीं है. सिर्फ you have to understand this part. The displacement current is negligible in good conductor. That's it. तो whenever you are getting a conducting current, तो यहाँ पे ID का वैल्यू क्या मिल जाएगा? 0, because their electric field is not changing, so flux is not changing. The addition of displacement current to Ampere's law results in unification of electric and magnetic phenomena. So because of this displacement current, हमने क्या देखा बच्चा लोग? We have got this idea that the time varying electric field, will produce magnetic field also. So we got a relation between electric field and magnetic field, that time varying magnetic field will produce electric field and time varying electric field will also produce magnetic field. और इसी का फिर आप like on this basis only you can understand the concept of propagation of electromagnetic waves. ठीक है, वो मैं आपको introduction में पढ़ाऊंगा. ठीक है, when I'll be teaching electromagnetic waves in theory, I'll teach you कि कैसे propagation of electromagnetic waves होता है. Alright guys, तो ये चीज आप प्लीज समझना आगे के लिए भी. From this topic few numericals can be asked to you. बहुत ही आसान सा न्यूमेरिकल होता है. ठीक है, like I have added few numericals here, 1, 2 and 3. So guys, when you are coming for the next class, please come with the solution for these 3 numericals. ठीक है, आप प्लीज इनको देख के आना. And next class will be a boards class for electromagnetic wave. वहाँ पे I'll teach you the introduction part, the propagation of electromagnetic wave, the properties of electromagnetic wave and the Maxwell equation. So most probably on Saturday we'll have a boards class on electromagnetic waves. Alright guys, या कल ही कर लेते हैं. So thank you बच्चा लोग, thank you for attending the class. Stay safe, stay healthy and have a nice day. Enjoy, buddy. Bye bye. Take care. Manish.